A box with a square base and no top is to have a volume of 108 cubic feet. Find the dimensions of the box which has the least surface area. The first step in an optimization problem is to identify what needs to be optimized. The least surface area is what we are trying to optimize. We're trying to minimize surface area. We can do that in conjunction with knowing that the volume of the box needs to be 108 cubic feet. So a box with a square base with no top will look something similar to this. And I'm going to call the height of this box h, and I'm going to call the side of each base s. So the optimization equation for the surface area of this box will be the surface area will equal s squared for the base plus 4hs for each of the four sides, 1, 2, 3, 4. And there is no top. Now, in order to help optimize that, we know the volume, which is 108 cubic feet, can be computed by multiplying the base of the square, which is a square, times the height. We can now solve this equation for one of the two variables, and I'm going to elect to solve this for h. So this tells us that h will equal 108 over s squared. Now that this equation has been solved for h, I'm going to substitute this value in for h into the optimization equation. What that does is that gives us the optimization equation in one variable. So 4 times 108 over s squared times s. To simplify this, I will do some simplification to the second term. That will give s squared plus 432 over s. That is the equation of the surface area, all in terms of s. Now that we have an equation, we need some sort of feasible domain, which I will write over here. The feasible domain for this, the side of our square base in this picture, would have to start at 0. The side cannot be anything less than 0. But since this is a square, the largest we can make a square of 108 square units is if we make each side of the square the square root of 108. The side of that square can be any number between these two. So now that we have some feasible domain, we can go ahead and take the derivative of this equation. So the derivative of the surface area is 2s minus 432 over s squared by the chain rule. And we should set this equal to 0 and solve for s. And when you set this equal to 0 and solve for s, we want to multiply each term by s squared to eliminate this denominator. And what that allows us to do is get into an equation that is workable and much easier to solve. When you add 432 to both sides, it's 2s cubed equals 432. And when you divide both sides by 2, you'll get s cubed equals 216. And that tells you that the s equals 6. The cube root of 216 is 6. So there's a side there that will minimize the surface area of the box.